We're going to start working through section 6-2, continued here with some more ellipses, just a few examples, and it'll be some problems for you to work on that correspond to this section. So write some more equations is what we're going to focus on today. A couple of ellipses passing through given points, as it says there. So this first one now, ellipse passes that point, 5, 2. The distance between the foci is 18, and the length of the minor axis is 6. I want to find the sum of the distances from P to the foci. So this is a new phrase that sounds is not something we mentioned in class. So we're going to focus on what that is and what that means here in a second. But we're going to treat this. We're going to start with just kind of our normal routine for writing equations. We need the direction. We need the center. And then we need A, B, and then possibly C. So if our direction is, it says here, or it doesn't give us a direction necessarily, but it does give us this minor axis length is 6. So as we all know from class, the length of the minor axis is 2b. So 2b equals 6. B is going to be equal to 3. What we also know from here, it says the distance between the foci is 18. And so I'm going to go back to the PowerPoint from the previous day, and we talked about here, again, the distance from the center to a major axis vertex is A, distance from the center to a minor axis vertex is B, and distance from the center to the foci, or to a focus, is C. The distance between the foci, that's going to be 2C. So if we go back to this now, it says the distance between the foci is 18. We're going to know that 2C equals 18. And therefore C equals 9. Things that are also helpful for us, we're going to have B squared, that's going to be equal to 9. We're going to have C squared, and that's going to be equal to 81. So now that I know this, I don't need to have the, we're looking for the sum of the distances from P to the foci. So we set this up as writing an equation, but we don't even necessarily need that. I'm going to go back to this slide over here from the previous day. So we talked about what the length of this major axis is. The length of that major axis is, is going to be 2a. So that means all the way across here, I'm going to change color, all the way across from this vertex to this vertex, that distance is 2a. And so comparing this to what we have here, the sum of the distances from P to the foci. Remember, P is some point on the ellipse. So this right here, this value right here, could be P. From the definition, as we now can see, the definition of an ellipse, that tells us the distance, the sum of the distances to those foci is constant. So that right there is the same. Again, we talked about this in class. As if I put another point right here, and it would be the same as that distance right there, which would be the same as if I put the distance right here. All those distances, the blue, the green, and the black, those would all be the same, all constant, no matter where I put that on here. So another way to think about this, the sum of the distances from P to the foci, what that's also known as, I'll keep it on this for a second, what that's also known as is 2a, which is another way of saying the length of the major axis. So when you see something like this, the sum of the distances from P to the foci, we're looking for what that's describing. We're looking for the length 2a. So again, although we started setting this up initially as a writing an equation, we don't even need that. We have B already, we have C already. So now we can find A. C squared equals A squared minus B squared. C squared is 81. 81 equals A squared minus 9. A squared equals 90. So that's A squared, so we do have to find A. A is going to equal 3 radical 10. And again, the sum of the distances from P to the foci, that is 2a. So 2a in this case, 2a is going to equal 6 radical 10. So the sum of the distances from P, this point right here, to the foci is going to be 6 radical 10. switch PowerPoints here. Sorry about that. So this next example, here we're going to write an equation this time. So ellipses have vertices at 3, 1, and 9, 1 and passes through that point. I'm going to write the equation of an ellipse and go from there. So we're going to treat it says these vertices, we're going to treat those as major vertices. So here is kind of our graph. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are roughly spaced. And then we'll put 1 here for, that was bad. Let's try that one again. There we go. That's better. So we have 3, 1 as one of our major vertices, and then we have 9, 1 as another one of our major vertices. So we're writing an equation now. So we want the direction of the major axis, we want the center, we want A, B, and possibly C. So our direction, if our major axis is going this way, left and right, our direction is horizontal. And because we can find this is this whole thing, there's our 2A again. So 2A equals 6. A is going to equal 3. I can count 3, 1, 2, 3, and find our center. Our center is 1, 2, 3, 4, 5, 6, comma 1. We also counted back 3 and got to that same point. A is 3, so we know that. We don't have B, we don't have C. In our problem, it says nothing about either the minor axis or the foci. So what we're going to have to do is, let's first set this up into our equation so far. We have our center, we have the direction, we have A. We can fill in a lot of what our equation looks like. X minus 6 squared over A squared, which would be 9, plus Y minus 1 squared over B squared equals 1. So there's our equation. There's what we know so far. The other piece of information from the problem is it passes through this point 7, 3. As we've done with both parabolas and circles so far, this is an x value, this is a y value. In our equation, we have an x and we have a y. So if we need to find b squared, we need to plug those values in and solve for b squared. So I'm going to plug those in. I'm going to get this. X is 7, 7 minus 6 squared over 9, plus 3 minus 1 quantity squared over b squared equals 1. 7 minus 6 is 1. Squared is 1. So I have 1/9 equals 3 minus 1 is 2. 2 squared is, equals, sorry. 2 squared is going to be 4. 4 over b squared equals 1. And now we're just solving for b squared. I'm going to subtract 1/9 4 over b squared equals 8/9. Go up here now. 8 times b squared equals 36. B squared equals 36 over 8. B squared equals 9/2. So we don't need b because in our problem we have b squared. Now when we plug this in, I can get rid of this b squared now, and I can plug in our value, which is 9/2. But that's a fraction over a fraction. You know, that's not the best necessarily. It's a little easier to see if it is not written like that. So we don't want to leave the 9/2 in a denominator. So I would just rationalize this fraction here, and my final answer here would be x minus 6 squared over 9 plus 2 over 9, or 2 times y minus 1 squared over 9 equals 1. Again, I just rationalize that second denominator. That's fine just to do by itself. One last example real quick, and this will be all for today's lesson. Write an equation of a circle with center 3, 5 that is tangent to the y-axis. So I know the quiz that we were scheduled to have was going to have some circles on it, and this is just some good information to remind you what tangent lines are. Let's draw these. 1, 2, 3, 4, 5. 2, 3, 4, 5. So 3, 5 is our center. There's roughly our center right there. So we can write most of this, x minus 3 squared plus y minus 5 quantity squared equals r squared. It says it's tangent. If you remember from geometry, a tangent line is tangent to a circle if it touches exactly one spot. So I'm going to put, here's our center. I'm going to make our circle. If it's tangent to the y-axis right here, now we can see what the radius is. This is my circle. There's the center of the circle, tangent to this line, the y-axis. So I know this distance right here is my radius. My radius is going to be 1, 2, 3. So my radius is 3. This is r squared. Get rid of r squared. 3 squared is 9. So there is my equation of a circle that is tangent to the y-axis with that center, 3, 5. If you like what you see, go ahead and smash that like button, and don't forget to subscribe.